In this video, we're going to go over two millivolt meters pretty much. This one's made in late 1980s, and this one's the modern one. Now, guess which one's more accurate? And if you're guessing this one, you're correct. It's actually the older one that's actually more accurate. I mean, this one's pretty much dead on accurate too. I'm kind of surprised. This one here should have been out of the box freshly calibrated, and for reference, I'm actually using a freshly calibrated generator because this thing I sent off for calibration about 2 months ago and stuff like that, and it's fully been recalibrated and everything. The reason why I did that was because I had to rebuild the output amplifiers on and also change all the surface mount capacitors too as well, because all the surface mount capacitors on the generator board and on the output stage and stuff like that, they all were testing like resistors, and I'm talking like 40 ohms, so I went ahead and changed them all. Also rebuilt the output amplifier and stuff like that, and then I went and sent it off to calibration and stuff, so it's dead within spec, and I'm going to go and show you that. So right now, I'm going to go put 200 millivolts. We got no load, so it's going to measure a little bit higher than it should, but I go and put that on there, and you can see it's pretty much bang on. It's 200, it's measuring on a meter, 202, 6, which is pretty close enough. And you know what I mean? That's what I got it set at, right? So we're going to go ahead and load it, because that's what I'm going to do when I hook it up to the meters over here. And then I'm going to show you what to test load it pretty much. So I'm going to go and add this and set the generator up, and I'll be right back once I'm done. So I went ahead and set up this meter real quick, put even a 50 ohm load on there. And we're going to go ahead and see what the output is coming out of this generator there. And it's at 1 kilohertz, and you can see there it's reading pretty much bang on, but it's 199 millivolts. You never get a meter read exact because you're going to have cable loss and everything else like that you got to take into consideration. But it's dead on enough pretty much. And we're going to put that signal directly up here. So we're going to disconnect this here. Alright, and then we'll go ahead and plug this into this meter. We got it on the 300 millivolts range there, so we're going to plug that in there, and you can see there it's pretty much bang on. It's reading about 199 millivolts, which is quite impressive actually. You can see the accuracy of this meter, and it's accurate pretty much in all ranges. You can even go there, and you can see there, and so forth. But you can see that meter is fairly accurate, right? We're going to go to this brand new meter out of the box, by the way. So we're going to take this here. So let me go and try there and not hit the record. Sorry about the bad record angle. All right, let me get my finger out of the way. We got it at 300 millivolts, all right? Okay, let's go there. And what is that reading? It's reading about 189, because it's not right at the 190 millivolts. And the scale I'm reading is this second scale below the top scale there, where it's close by the 2, and you can see there that's reading about 190, 189 millivolts. It's quite a bit off, and unfortunately I noticed this on all the ranges. You know what I mean? I go to 1 volt, alright? Same thing like I did on the other one, and actually I'll say that's a little bit better, but it's still somewhat out. It's improved. It wasn't as good earlier, but yeah, this scale here though, I wouldn't say that's well calibrated, so I'm definitely going to have to work on calibration on this thing. Now the good thing about it is, bandwidth wise, it does do up to a megahertz. So I can go ahead and set the frequency. Let's just go back. Let's go frequency, and let's just go up to 1 megahertz. Why not? Alright, 1. And you can see there, it didn't drop off much at all. And you can see there, it's actually doing 1 megahertz. So frequency response is actually what they came. Doesn't ever drop below the -3 dB point. So it's very good, at least as far as handling the frequency response and stuff like that. But accuracy is a little bit off, so I'll have to figure that out. But other than that, it's a decent meter. I mean, I don't have no problem like the other guy did with the cable connections or anything like that. It's actually been solid, and channel 1 and channel 2 does track proper. One thing I know is the accuracy. It's not as good as this one. So, and this one here is bang on everything pretty much. Right now it's picking up noise. I got to disconnect this because that's acting as an antenna in the millivolt range. These meters are actually pretty sensitive, so that's one thing to be careful of. But I'll go and probably do a more detailed review on these meters later on and do a teardown comparing the two meters so he can show you the inside of like the modern one versus the old one and so forth. But there you go pretty much. So went ahead and I'm gonna go and set it up to the 100 millivolt range here, and we're gonna set it at 10 millivolts the output on the generator so you can see how accurate this is. All right, see there, it's pretty close. It's right there at 10 millivolts. Let's just go ahead and put 20 millivolt now. You should be right there at the 2, right? Now let's go 30 millivolts. You can see it drops off a little bit, but that's to be expected. All right, 40 millivolts. All right, you can see there it's still pretty close. All right, 50 millivolts. All right, see there it's right dead center pretty much. Or 60 millivolts, and we're gonna do the same test on the other meter. All right, 70 millivolts. Alright, you can see it's pretty accurate. 80 millivolts, alright. 90 millivolts, alright. Now let's go 100 millivolts, alright. It's pretty much as full scale, and you can see right there, it's reading fairly accurate, alright. So now I'm going to go ahead and plug this into the second generator, and we're going to do the exact same test pretty much. So I'm going to go ahead and run the same test as I did on the older meter on the newer one now. So I switched the signal generator over to the TVT-322 meter now. And we're going to go ahead and put 10 millivolts and see how accurately it reads. And I got to say, that's pretty much bang on. That's actually good. Alright. So we're going to keep going up and we're going to run the same test. 20 millivolts. Yeah, it's pretty close. On this range, I got to say, it's going to be pretty accurate. Alright, so 30 millivolt, 40 millivolts, 50 millivolts. Alright, and yeah, that's where it starts to get a little bit off, as you can see, where this one here is reading dead center. Alright, 60. Yep. 70. And you can see how out it gets pretty much the higher it goes up. 80, 90, and then 100 millivolts should be full scale. And you can see there compared to this one was tracking very accurately, but it seems like after you get past 40 millivolts, that's where the accuracy falls off pretty much. So there you go, and that pretty much compares this older millivolt meter to this newer one. And I just kind of want to show the accuracy between something made in 1980s where I only had to clean the contactors and the switch and do a quick calibration on. That was it. Didn't need no capacitors, nothing changed out at all. It was easy to find the service manual and stuff for it. So I was able to get this one fully recalibrated, but this one here should have came calibrated out of the box. So I'm going to have to figure it out on this one because I noticed that on the higher ranges, let me turn that off, that it's actually pretty out. Like on the lower ranges, below 40 millivolts, it's fine. And it seems like above, I noticed like the 10 volt range is okay too. But anything in between there, I know it's out a little bit. So I don't know why. I guess it probably was the equipment they were using to set it up because both channels do track the same. So I can actually put this on this channel, and I can even put a splitter and run both the channels, and they actually track evenly and stuff. So it was whatever equipment they were obviously using to calibrate this was out of calibration or something. Who knows? But either way it goes, I'll figure out. It's not a big deal because I believe this is made like the Leader 186. I'm not sure exactly which model it is. I'm just coming out with something off my head, but I know it's made off one of the Leader ones, and someone said that the pods and stuff like that are pretty much the same on that. So I'll have to figure out how to calibrate this thing, because obviously you're probably not gonna find a service manual for this thing, so I'll have to kind of figure that out on my own so I can get a little bit more accurate and to track as good as this one does. And this one reads the same as my fluke meter and also meets the same as the oscilloscope and the old one, also portable oscilloscope, so I know it's dead on accurate. But there you go, pretty much. So this is going to be probably the last part of testing, at least as far as this TVT-322 Dual Millivolt Meter. We're going to test the frequency response of this meter. And pretty much what I'm going to do is I'm going to set 1 volt RMS AC into this meter, and then we're going to test it from 10 hertz all the way up to the megahertz claim that they claim. And we're going to see kind of where it drops off. So we're going to take a measurement at 10 hertz, which it should pretty much read, you know, closest it's going to get. And then we're going to see where it starts to slowly drop off like this as we increase the frequency and stuff like that. Now, I'm not going to go through all the frequencies and stuff like that. I'm just going to go through a few key frequencies. I'm going to see kind of where it drops off. So here we go. And I do got the signal generator set at 10 hertz right now. And we're going power up. And there you go. You can see it's getting about 950 there. So it's still within the 5% accuracy. That's what they say. I mean, it's pretty common. All these meters are about 5% tolerance and stuff like that. So I say it does actually meet its accuracy, even though earlier I was saying the equipment they were probably using wasn't calibrated well. But I did the math, look back into it, and it is doing about 5%, which is what they claim in the manual. So it is working as specified. Well, let's go and see the frequency respond. Let me quit yapping my mouth. So we'll go 20 hertz, alright. See there? Kind of interesting. Took a drop, but we'll go ahead and go 60 hertz now. Yeah, it's staying around there. Okay, good. Alright. We'll go 50 hertz. Why not? Go down instead of up. Okay. We'll go 100 hertz. Alright. And we're keeping the voltage the same, by the way. We're just looking where that needle drops off. Okay, you know something? We're just going to go ahead and kind of go across, and we're just going to go ahead and... So I'm increasing the frequency. I'm at 200 hertz right now. And we're just doing it with the knob now. We're just increasing the frequency. And we're getting close to about 400 hertz. And you can see there. That's pretty impressive. Alright, where are we at now? We're at... And let's just go back down to 600 hertz. So we're at 600 hertz. I'll show you where it is on the display. And there you go. And that needle has not moved. That's impressive. Okay. Also tells me the signal generator is very flat. But of course, being recently calibrated, I would expect that. Okay, we're at 800 hertz. And now we'll get up to 1 kilohertz. Okay, let's see now. We'll slow it down. Yep, we're at 1 kilohertz now. And you can see that needle's pretty much stayed where it's supposed to be. And there you go. So now we're going to go ahead and go over here. And we're actually going to increase it in 1 kilohertz steps. So let's do that. Okay, we're at 10 kilohertz right now. And just leave it right there real quick and show you it's at 10 kilohertz. And that needle did not move. So we're going to go up now. And we're just going to keep increasing it. Okay. And you can see that's rock solid. We're at ready now. And I'm just looking at both here. We're at 200 kilohertz. You can see there 200 kilohertz and that needle has not moved. Okay, so we're going to keep going up. And we're going to go up until we start seeing a dip. So we're just going up. And we're not seeing no movement at all. 366, still no movement, so keep going up. And we're going to go up to the megahertz, and we might even go further than that if it... Okay, we're at like close to 600 kilohertz. And like, okay, there we go. I think let's go back real quick. Did that thing there, where did it start moving? It just moved a little bit. But it's still, yeah, it dropped off a little bit, but it's still holding in. Yeah, and there you go, kind of see it there. We're at 683 kilohertz. And it's well within spec. I gotta say, I'm quite impressed. Okay. Yeah, now we're starting to drop off here, and it just ever so slightly, but it's holding stable. Okay. And I think we're getting close to a megahertz now. And yeah, we're right at a megahertz. You can see right there. So this thing definitely does as its claim. I gotta say, I'm quite impressed with that. Let's go faster though. Let's go ahead here. We'll just keep increasing at the level we do it. Yeah, you can kind of see that's where it starts to fall off, but we're still within the -3 dB mark, so let's just keep going until it gets really wonky, I guess. But yeah, it's not gonna be accurate at these high because it's not advertised as that. But let's just keep going. And yeah, we're at a megahertz and a half. I got to say, it does actually pass the specification on this one. Okay, now we're hitting about 900 millivolts, but we haven't dropped off yet. Let's just see where we keep dropping off. I want to get it down to about 7. Okay. And we're just increasing it at the same speed we were before. Now we're at 2 megahertz and 47. And you can see she's holding in. Granted, it's not going to be accurate at this measurement, but you can kind of, you wouldn't expect it to be. Still pretty good, actually. Okay, we'll go a little bit faster or slower, I don't know, but we're increasing that frequency pretty quickly. And let's just let it there. And yeah, she's holding. I am actually quite surprised. We're going to 3 megahertz now. I got to drop out by now. I'll be shocked if it stays in there. This thing definitely is holding in. Okay, we're taking a break here and there. We're at 3 megahertz. 3 megahertz, or around 3 megahertz and 9 hertz, but wow, I can't believe that actually still holding in. That's way past the spec. So, you know something? We're gonna go up. We're gonna go and change it there. We're gonna go up to the hundreds now just to see. Yep. Okay. We're at 4.7. That's where it starts, Okay, we're gonna get it right there. We're gonna go ahead and go down. We're gonna see right where it falls out. Okay, so we got it at 3. So that's right around where it is. 4.5 megahertz is right where it actually starts to drop off, below. So this meter is very, very good, actually. I gotta say that I'm quite impressed. It does do its rated specification, of course, as we go down. Now it goes back where we originally started, and it's good. So there you go. This meter is actually good up to 4 megahertz, I would say. But as far as accuracy, you want it that accurate about, of course, the megahertz as they claim and stuff like that. But yeah, it won't drop out much, even at 2-3 megahertz, which I was kind of shocked. So yep, it is pretty good. So now I'm gonna do the same test on this meter pretty much. So I went ahead and kind of imitated the same setup that I did on this meter here, and we're at 1 volt RMS. And you can see there we're at 1 volt AC RMS at 10 hertz. And you can see there, very accurate. It's a little bit more accurate than this one, actually. But let's go ahead. We're not doing that. We're testing frequency response. So see right around where it drops off. Okay, and where we're at 1 kilohertz already. Okay. We're at 2 kilohertz, alright? And we're just going to do the same thing we were doing. We're just going to increase the frequency on the fly. Okay, let's go up to 4. Now this meter is rated to do about 600 kilohertz with no problem. Okay, and let's just go ahead and do the same thing. We're gonna go and do it quickly. 7, 8. Let's just set this here to 20 kilohertz, alright? And you can see there that needle has not moved and it's very accurate, alright? So we're gonna go ahead and go now a little bit larger steps. Okay, where are we at right now? Let's just do 100 kilohertz. Now we're at 100 kilohertz. And I'll go ahead and show you. You can see it's at 100 kilohertz. And yeah, it dropped off a little bit to be expected, but still holding in pretty much. So we're just gonna go up. And yeah, much movement at all, if any. And I'm getting close to 300 kilohertz, not 3 megahertz. And I'm just looking for any needle movement, and then I'll show you where I'm at right now in a minute once I get up to the 500. Okay. And you can see there, we're at 500 kilohertz. And yeah, she's still reading pretty accurate, so let's just keep increasing it. And this one says it's rated at 600, and that's where it's okay. You guys see it dropped off a little bit. Let's just keep going up. And yeah, it starts dropping off at about 680 kilohertz, so yep, let's put it back. Let's go back up. So it's doing what it's rated though. It's not as high as this one, but I wouldn't expect it to be anyway. But let's just go back to 600 kilohertz. As you can see there, it's pretty accurate still. So there you go. Actually, we're at 601. But right when I get about to a little bit past, yeah, about 658ish or so, that's when it actually starts to drop off. So that's pretty much the bandwidth of this thing. But overall, yes, this one does have better bandwidth, but a little bit less accurate. But as far as the conclusion goes, let me go and turn this off. I don't need it on no more. As far as the conclusion goes, would I actually recommend anyone to buy these meters, these TVT-322s, or any of the dual pointer meters that they make? Because they actually rebadge these under other brands stuff. Yeah, I do actually. Because nowadays, no one really makes a millivolt meter, you know, anymore. At least an analog one, so they're hard to come by. 2, it can handle the frequency response. And 3, it does actually meet its accuracy about 5% or so on most of the ranges and stuff like that. So even though, you know, maybe a little bit out here and there, it's still well within its specs that it mentions in the manual and stuff like that. And it's a dual pointer meter, so you can use this for, like, of course, what I'm gonna be using it for biasing cassette decks, of course, for peaking and everything else and stuff like that. And it's gonna do great a job, and it's better alternative than normally I would tell most people, yeah, buy the older meters because they're better built and stuff like that. But I do realize that most people don't want to go ahead and have to spend time in fixing the meters and stuff like that when they get them. Yeah, sure, Leader makes great meters, this company makes great meters, I mean, and everything else though, but how many people do I expect to have to want to tear down the meter to go ahead and, you know, get it calibrated and everything else like that? Because chances are, you know, the eBay sellers are not going to do that. And it's going to probably likely come broken as is, and you're going to pay over $200 for it. Where you could get this thing brand new for about, you know, $1.50 in the States. If you actually order from AliExpress or something like that, you'll get it for about anywhere from $1 to, you know, $1.40 or so, for depending on who you buy it from. I wouldn't pay more than that because then you're overpaying some other seller there. But typically you see them for about anywhere from $100 to $150. So that's what you would pay for a brand new meter. And so long it doesn't come damaged and it's well within reason, you can actually use this out of the box, and it has the BNC connectors and stuff. And if you look at the BNC connectors, they actually upgraded from the one that the guy did a Unity version of this, where it came cracked BNC connectors, where if you moved it, it disconnected and stuff like that. they went ahead and actually put a gold center pin BNC connector, gold plated I should say. It was real gold, that would be nice. But you know, they went ahead and fixed some of the issues with the Unity that he actually did a review of and stuff like that. Now, I'm not saying nothing wrong. These older meters are great, and as you can see, this thing's dead on accurate pretty much, and so forth. And it's made from 1980s and stuff like that, but I did have to service it. You know what I mean? It just didn't come out of box like that. And that's the problem when you buy a lot of older test equipment and stuff. You will have to do a service on it because components will drip, and not just capacitors. I'm talking like resistors and other active components that will fail over time and stuff like that. Then you got to find an appropriate service manual so you kind of can have an understanding what it's doing without having reverse engineered and stuff, and then go through the problems, fix it, and then after you fix it, you're likely going to have to do a full calibration and stuff like that too as well. So that's things to keep in mind when you're buying an older meter and stuff like that versus buying one out of the box. So yes, I definitely recommend that for anyone that's into, you know, tape deck alignments and stuff like that, or reel-to-reel alignments and stuff, because they're valuable too. Even if you're just using it for peaking and stuff like that, it's a great meter to have around. So yes, I do recommend that meter.